All right, hi everyone. Welcome to DataverseOS workshop. My name is Xiangyu Fu. I'm the co-founder and CEO of Ownership Labs. Today, I'm here to help you get started with building applications on DataverseOS. First, I will tell you a little bit about what DataverseOS is, and then we'll go through some key conceptions of DataverseOS to help you understand the whole system. Then I'd like to do a brief Bounty description to talk about what's the idea we want you guys to build during this hackathon. And last but not least, I want to walk you through a simple demo and some actual coding to show you how to start developing on DataverseOS with our SDK. So you can see my Twitter handle and my email here. So if you have any questions during this hackathon or you have any feedbacks, welcome to contact me. And you can also find me on the Discord server. So yeah, if you have any questions, welcome to contact me and I will always be there to help you. So first, I want to mention our bounties and prizes for this hackathon. Again, we are providing $3,000 in total for the most innovative use of DataverseOS. So for the first prize, for the first place, we provide $1,500 and $1,000 for the second prize and $500 for the third prize. So we want you to build. First is to explore the dApp, DAO, social files, and AI use cases. Second is integrate Dataverse Wallet to interact with FEVM. And third is to create toolkits with partner technology for composability. First, I want to talk about what is DataverseOS. DataverseOS is a Web3 native operating system as a new kind of user and terminal to visualize all the data files over different applications. The operating system consists of three components. First is our data wallet. Second is the identity computer, and third is the ecosystem built with our SDK. Okay, so first I will give a brief introduction to the data wallet. Data wallet is a Chrome browser extension, and it's a gateway to Web3 dApps for safely holding users' identities and resources. And before your development during this hackathon, I highly recommend you to update this extension to the latest version. And if you have already installed this data wallet, maybe you want to check that the newest version of the data wallet is 0.5.39. Yeah, and anyway, so we built this data wallet as the gateway to Web3 dApps to help users store their IDs and manage their access to data resources. And for developers, the data wallet provides system calls that allow apps to connect to a user's identity, obtain for users' signature permission, and read and write data to their private data space. And here are some types of the system calls in addition. And the data wallet is responsible for preventing bad apps from stealing users' data that we will talk about later. And second is the identity computer with a built-in encrypted file system. The encrypted file system is a place to hold all the data that user created by interacting with the applications built on our operating system. So it's like a file system on traditional PC or MacBook, but it's fully decentralized and 100% owned by your identity. And within DataverseOS, all the data that user generate will be saved in this file system, and it can only be accessed by user themselves, as nobody can access your file system without your permission, including the Dataverse team. And the data stored in this file system can be very diverse. You can store personal data, your social connections, user profile, user-generated content, and your contribution in a DAO, etc. And all of these will get collected and saved in this one place. And we also get a SDK for developers to build all sorts of personalized services on top of this file system. So basically, the file system is a secure cyberspace for users, and is a programmable storage layer for developers to power their applications with data sovereignty and data privacy. Okay, so it's totally isolated at the application level. Normally, application, normally like app 1 cannot access data on the web app 2, and we are designing something like a data pool for data sharing between applications with a whole tokenomic system for it. Okay, and I want to talk here. I want to talk about what's the difference between DataverseOS and the traditional operating systems like Mac OS or Linux. But before this section, I want to clarify that when I talk about data here in this context, I'm referring to all the information that could be digitized and stored electronically. So before we dive into the differences between DataverseOS and the traditional operating system, I want to take a quick look back at the history of data, of personal data. First, we've got personal computers locally, and we interact with these softwares on our PC, and the data generated was stored in our hard disks. At this stage, we actually had the control of our own data, but the thing is that it's not really easy for other people to access it because there's no internet. And it's like that we are living in our little data islands, and there's no measure for data sharing or making the data flow. And the second period is the appearance of the internet, which totally changed the game. And suddenly data could flow freely between different devices, and we could access all sorts of cool stuff online. However, this is also the beginning when we started losing control of our data because of the centralization of today's internet, because all the computing and storage happens in a centralized way. So in this stage, we've given up our data sovereignty in exchange for the convenience of the Web 2 internet. And now we are looking at Web 3 era. So Web 3 is the internet where data is computed and stored in a decentralized way. That's why we came up with DataverseOS. It's the next generation personal computers. It's decentralized on the cloud and fully controlled by your identity. And basically, we designed this system by replacing these traditional hardwares like CPU, like memory and hard disk, with decentralized infras such as blockchains, decentralized data networks, decentralized storage and databases, and so these infras can help us give the complete control over data back to users themselves. And the next generation personal computer is going to take the best of both the convenience of the cloud and the security and privacy of a local PC. So in summary, DataverseOS will control and manage protocols, coordinate protocols like Dynamic and Delete and Lens, and other Web3 protocols to make it easier for developers to create all sorts of cool applications on top of these protocols. Okay, and here are some resources that can help you get started. Here is our official website. It's dataverse-os.com, and our developer documentation. We've just published a brand new version of developer documentation like a week ago, and it is, I believe it's 10 times better than the original version. Yeah, and you can find our SDK open source on GitHub. And these two are example projects we provide for you to, that may help you to build your own application during this hackathon. Dataverse Playground is a Web3 social application like a Web3 Twitter, and Arazo is a Web3 note-taking application like a Web3 Medium. And you can always find us and seek for support in our Discord community or Telegram server. Okay, so before we dive into continue these slides and dive into other sections, I want to give a quick demo over our system. So our product is actually live, and you can try it out by yourself on dataverse-os.com. But before that, you need to download and install this Dataverse extension. I've already installed it. With this extension, you could sign into this operating system. And here is a user dashboard, and you can see some statistics like your token assets and data assets and the total number of your streams here. And below is a dApp launchpad to show which ecosystem applications you used recently, and you can favorite them to the dock on the left side. So the first application finder is exactly the encrypted file system I've talked before. It's a file system like the Finder on a Mac to securely manage and visualize and tokenize all the data you've created. And the second application here is Playground. It's like I said before, it's a Web3 social application, like a prototype for Web3 Twitter. Let's just try it out by post something here like hello good ownership hackathon and a picture here and post. And by clicking on the post button, we actually create this post as a data stream on the Ceramic data network. Okay, and so we just create a post under this Playground application, right? The difference of our operating system is that you can always find this post as a file, safely, automatically saved in your personal file system. And like here, you can see that it's just created a minute ago. And here we have the built-in tokenization solution. You can monetize this file. Let's just make a test. So we set a rather low price, like we just want to release 1,000 copies and encrypt both text and images field. And this will switch to the Mumbai testnet, and you need to sign a signature message by Nan's profile, and this transaction is to deploy NFT smart contract on the Mumbai test network, because the tokenization, to put it simply, is to release a collection of NFTs which will be used as unlock credential, so that only the NFT holders can access this exactly this post, the content of this post, and retrieve the secret key on the lit network to decrypt this content. Yeah. So we just monetize it, and by monetize it, I just mentioned that we actually encrypt this with a secret key and put the key on the lit network and use unlock NFT as a credential to retrieve this secret key, so that you could use this key to decrypt the content and get access to this data. So back to the Playground application, let's see what changed. Yeah, we can see that it was public, and now it is encrypted, and you need to pay this amount of Wmatic to unlock it. Yeah. So basically, this is an example to show how DataverseOS can power ecosystem applications with data privacy and data sovereignty and a built-in data monetization solution. And later, I will do some extra coding to show you how to build an application like this Playground application. But before that, I want to back to the slide and talk about why we built this DataverseOS. To put it simply, we built this Dataverse operating system to bring security, because the fact today is that all the latest data networks are built on these two EIP standards. These two standards define how users can create identities, authenticate with applications, and manage data resources. However, it's worth noting that signing with Ethereum entirely relies on the signature. So if some bad websites get the signature, users' data resources will be stolen. So it's us developers to take the duty of ensuring that user data can be safely stored and beyond the reach of other applications, like the bad applications. So DataverseOS implements a new security layer to ensure that CB signatures are authorized to the correct application. And you may wonder how we achieve this. Step by step, first, we ensure that each application has its own independent file system and the scope of data resources it can access. And second is that users' data under an application will always be encrypted before it's put in the file system. And when an application asks for decrypting users' data, assigning with Ethereum signature must precisely match the scope of the application. And lastly, DataverseOS ensures that the applications can only request signing with Ethereum signatures that only include valid resources, and the cross-application requests will be denied. So in summary, we protect the data security by building this signature to resources mechanism and keep the signature safe. Okay, and here is the composition of our operating system. It's rather similar to the traditional operating systems like Linux and Unix operating systems. We've got a Dataverse kernel here, and it exposes system calls for developers to interacting with these kernels. And we have user interfaces. Now it's a Chrome extension, and in the future it can be a browser or a Linux distribution. We just partnered with Linux Foundation like a month ago, and so it's very possible that we will release a whole Linux distribution as a DataverseOS interface. And lastly, we have protocol drivers. Protocol drivers are open architecture for developers to integrate other Web3 protocols into DataverseOS. Here's a brief overview of the tech stacks behind DataverseOS, and hopefully it can give you a simple total view of how our system works. In general, our system integrates and coordinates protocols like Nance, Ceramic, Lead, Fluence, Ethereum, Filecoin, and other Web3 infras. We use Nance as a application layer protocol. We use Fluence and Ceramic as a storage layer, and Lead as a access control layer, and Ethereum and Filecoin as the infrastructure layer. So the file system is able to hold all the files over different applications by linking data streams on Ceramic. Every time user creates a data stream, the OS will automatically create a corresponding file stream, bind the data stream to it, and save it to the file system. The operating system adds access conditions to the file so that data or content can be shared and monetized. And I want to explain by taking an example of posting a tweet in the playground, as I just showed before. The tweet is created on Ceramic Network as a data stream, and a file of this tweet, like a shadow file, will automatically be created in the file system, and we use Lead protocol to program an access control module for each data stream, each file stream actually. Thus, for each file stream, the operating system generates a secret file key to encrypt stream content and keep the key on Lead protocol's distributed network. So normally, only the data owner can obtain this key. But when we monetize the tweet, the OS uses social protocols such as Nance protocol as an engine to turn off-chain data onto on-chain tokens. And then we deploy a collection of NFTs after the operating system updates the lead conditions to retrieve the file key. The NFT here acts as an unlocking certificate. This means that only the NFT of the holder of the NFTs can obtain the file key, can retrieve the file key from the lead network, and then use it to unlock the stream content. So by the way, I would like to emphasize that this picture here only describes the underlying protocols of the current operating system. Our operating system is highly open in its architecture, and we are integrating more protocols into a system such as ARWave, FEVM, and others. Okay, so let's switch to developer mode here. I will do some extra coding to show you how to start developing on top of DataverseOS. Okay. Actually, here I create a folder called Dataverse Workshop. It's an empty folder here, and I would do all the coding and the programming under this folder. So I want to mention that before all the development, the first thing you will need to do is to create your Dataverse app. Actually, is to register your app info to our dev table, because the operating system needs to record the data models you want to use in your application and which application these data models belong to, so that we can ensure all the data resources created under these data models can only be accessed by your application. So we provide a CLI tool called Create Dataverse App. You just need to type npx create Dataverse App and then your project name let's take a root ownership hack, for example. And this command will initialize the project. And okay, after it's ready, we could open this project folder, and I need to. Here are some folders I want to and files I want to emphasize. So first, Dataverse config is a file to configure your application and to feed in the base info of your application. Like Slack is the only identifier of the application. Let's use this, for example. And the name of the application, let's build ownership hack. The logo URL of the application, I want to upload a image for here for the time reason. So I just do some random stream. And the website here, if you use this application for development or testing, you can use localhost and a port of your choice for testing. And default folder name is the name of the folder that the data user generated under application will automatically save to in our Dataverse encrypted file system. And description is a simple description of the application. And now we talk about the models field. But actually, the models field are referring to the schema files under this models folder. As you can see that we provide post and profile. These are two examples of GraphQL schemas we provided for as examples. And under the FS folder, these three schemas, content folders, index files, and index folders are the data models we are using in the encrypted file system of DataverseOS. So we highly recommend that you don't make any modifications or delete these three files here. And under the models folder and out of the FS folder, here you can define your own data models to use in your application or make modifications on the examples we provided here. For example, if I want to add a commands feature to the post, the post is like a post in a Web3 social application, So I can update this schema file. It should be a list, right? A command should be a list of string, right? And maybe you want to define a new GraphQL schema and for data model called node, like using it in a Web3 note-taking application. Node maybe should get a node should have an author, have version, and should have the content of the node and the title, right? Yeah. So this is how you create a new schema to specify the data structure you want to use in your application. Okay, back to the config. So the models here are referring to the schema files under this models folder. Like we just created a new model called node. We can add it here so that will be registered to your application in our data table. So in public domain, this field specifies whether you want to actually the Ceramic network encourage developers to make a collaborative effort to use these data models. If you are if you build a well-designed universal data model like user profile, you can make it public on the Ceramic data network so that other developers can find this data model and use it in their own applications. But we think that under some specific conditions, you may want some of the data models be private and could only be used by yourself. So this is public domain field specifies whether you want it to be public or private. And schema name refers to the file name under the models folder. And encryptable specifies which fields under the schema or under the data model could be encrypted when a user monetizes this file in our operating system. And the Ceramic URL, you can leave none to use Dataverse test Ceramic node. But if you are building an application in production, we highly recommend you to deploy your own self-host Ceramic node and put the URL here. Okay, so another important thing is that you may need a private key here this private key will have the root administration of this application. So here, for example, just for test, I will generate a new secret key and use here. So after configure your application in this config file and customize your data models under models folder and pass in the secret key in this file, we may install the dependencies. It takes a while. Install the dependencies, and finally we can deploy this application and register it to Dataverse dev table. Use this create Dataverse app command. And if it's successful, you should see it's successfully created. So now before we run the pnpm dev command to run the demo, I want to show you the output. So if the application is created successfully, there will be this JSON file under the outputs directory. It's a JSON file to specify all the information you will need of your application for further development, like the stream IDs of deployed data models and the other base information you just configure your applications. The stream IDs here are very important because it's the only identifier of this data model, and you may use it to like create a stream under a specific data model later in your development. Okay, so after all of this, finally we could run a demo, and let's check. Okay, so this is a demo built upon the runtime connector SDK we provided. So it's not all the functions we provide for developers, but it can give you a quick demo and a quick view of what features we are providing for developing your applications. So first, you can connect to user's identity, and this asking for a signature to give access to this application to access these 6 resources are 6 data models I've just deployed before. So this signature, if I sign this signature, I'm allowing this website to access the data resources under these 6 data models. And after that, we'll get a PKHDID as a capability to read and write over these data models. Let's try create a public post. this will create a data stream under the post data model, and it could be seen as a Web3 Twitter post or a Web3 tweet. Well, let's see if something goes wrong. It should be. Okay, seems like I just during my config before in this Dataverse config, maybe I just made some mistake and the data model could be corrupted or whatever. But never mind, you can always use this command to create your Dataverse application and run a demo to try it for yourself. I for the time reason, I will leave it. I will leave it for you guys to play around with. And another SDK I want to mention here is the runtime connector. Yeah, you can find it open source in our GitHub, and the runtime connector SDK provides the full functions for developing your application, and it also contains a demo, so let's have a try. But, as you can see here, the runtime connector provides a lot of functions for you to connect to user's wallet, switch the wallet network, and sign a message or call any smart contract on the blockchain. Get the current PKP deed that users has, and execute a lit action, get the dApp table info, and get the information of your application, and create capability to read and write on users' private data spaces. Check if your application currently is authorized to access users' personal data, and create a stream, update a stream, load a stream, or whatever. And you can check all the APIs here in our developer documentation. And I want to remind that our operating system is still heavily in development, so it may have some, APIs may change very fast, and it may have some bugs. So it will be so nice if you guys can contact me and give your feedback to us and help us improve the documentation and the operating system and product and the SDK together. Okay, I think it has been 30 minutes. So back to the slide, and let's make a quick end to this workshop. So all in all, the Dataverse operating system is a programmable data layer empowering super application. It's a place for users. It's a place to visualize and manage and tokenize all the data assets, centralized with their digital identity. And for developers, it's a platform, a data middleware with programmability and interoperability to bootstrap their dApps easily. So thanks a lot for tuning in, and I hope this workshop can help you understand better of how DataverseOS can help you securely manage and monetize your data. Hope you decide to develop use our SDK and check out the bounties and work on them. If you have any further questions, you can contact me on Discord server or Twitter or email, and I will always be there to help you guys. So hope you guys have fun hacking.